Okay, before this we have learned about two-dimensional vectors. So let's say now three-dimensional vectors. Okay, before this, when we see the two-dimensional vectors, is only involve the point x and y, but for three-dimensional vectors, it will be any point P that can be described as P x y z. Now you have 3 points where it involve the point x, the point y, and the point z. Because if we are sketch it in graph, it will involve three axes, which is the x-axis, y-axis, and we have one more axis here, which is z-axis. Okay, therefore it will involve the vector that will involve three direction, which is in the direction of x, in the direction of y, and in the direction of z. Okay, so let P is the point where it have the point x1, y1, z1, and another point Q where the point Q is x2, y2, and z2. Okay, be 2 points in space. Then the distance PQ between P and Q is given by x1 minus x2 to the power of 2, y1 minus y2 to the power of 2 plus z1 minus z2 to the power of 2, then we square root. Okay, it is same with the distance for two-dimensional vectors. Okay, let's say you have 2 points here. You have point A and point B. You want to find what is the distance between point A and point B, which is it will be the vector of AB, okay, in the direction of AB. So what you need to do is just square root of point x1 minus x2 to the power of 2 plus with y1 minus y2 to the power of 2 plus with z1 minus z2 to the power of 2. Then you square root everything. Okay, it's doesn't matter if you take x2 minus x1, is the same, but you need to remember, if you take x2 minus x1 to the power of 2, you need to do y2 minus y1 to the power of 2 plus with z2 minus z1 to the power of 2. This one is also correct. Okay, it's either you start with x1 minus x2 or x2 minus x1 is correct, because you have the power here, the square the power of 2 here. Okay, so this is how you want to find the distance between 2 points in three-dimensional space. Okay, let's see the example. Calculate the distance between the point 3, -1, 6, and -2, 3, 5. So this one is the x1, y1, z1, and this one is x2, y2, z2. Okay, therefore to calculate the distance, we take x1 minus with x2, so you have 3 minus with -2 to the power of 2 here. Then we take y1 minus y2, so we have -1 minus 3 to the power of 2 here. And then we take z1 minus z2, so we have 6 minus with 5 to the power of 2. Okay, so minus minus will give you plus, so 3 plus 2 will give you 5. 5 to the power of 2 is 25. Okay, -1 minus 3 is -4. -4 to the power of 2 will be 16. 6 minus 5 is 1. 1 to the power of 2 is 1. Therefore, you have the distance between these 2 points is square root of 42 units. So this is how we want to find the distance between the point in three-dimensional space. It is similar with the one in two-dimensional space. It's just that the three-dimensional space will involve another point, which is z. Okay? Alright. So now we want to see what is the vector in three-dimensional space. Okay, if before this we have seen the vector in two-dimensional space that can be written in terms of the basic vector, which is I and j. Okay, in three-dimensional space, the idea will be extended, where we will define three vector, which is I is when you have the value of x, but y and z is 0, means that I will represented the vector in the direction of x. Okay, and j will represent the vector in the direction of y. You see the value of y1 here. Okay, and the k will represent the vector that is in the direction of z. Okay, z here. Okay, where I, j, and k are unit vectors. Okay, so I is the unit vectors from origin 0 to the point 1, 0, 0. So you see, I is from origin, okay, to the x. J is the origin 0 to the point 0, 1, 0. J is the origin 0 to the point y. Okay, and this one is from origin to the point z. So this one is the unit vector that represent each direction. I in the direction of x, j in the direction of y, and k is the vector in the direction of z. Okay, this is the difference between two-dimensional and three-dimensional, where two-dimensional only involve the I and j. Okay, but three-dimensional we have another vector here which is k that represent the direction of z. Alright, let P be the point where it lies on the 3D space, where it has a point x, y, and z, be any point in space. Then the vector OP from the origin to the point P is called the position vector of P with respect to the origin the origin O, and usually denoted by R. Okay, this one is the same with the previous one. Okay, we have three axes here. Okay, we have axis x, y, and z here. If we have one vector where this vector you have point P, x, y, and z, okay, so this vector from the origin to the point P, we call it as a position vector, okay, or we denoted it with the symbol R. This one means the position vector. Okay, so to find the magnitude of the position vector, okay, the magnitude is the length of this position vector. It is similar formula to the two-dimensional vector, where we need to find it by using the formula square root of x squared plus y squared plus z squared. If just now to find the position vector, magnitude of position vector for 2D, okay, it will be involve only x squared plus y squared, but now we have additional point here which is plus z squared. Okay, so this one is to find the magnitude, and to find the unit vector, the formula is the same. Okay, to find the unit vector u, the formula is the position vector itself divided by its magnitude. Okay, so the position vector will be in the form of xi plus yj plus zk, where xi, yj, and zk we call it as a vector component. Okay, and we divide it by the magnitude of this vector. Okay, so let's say example here. Find a unit vector having the same direction as v equal to 2, 4, and 3. Okay, so sekarang kita nak cari unit vector that have direction v, 2, 4, 3, means that from origin to the point 2, 4, and 3, we want to find the unit vector. Okay, first we need to declare or define what is the vector v. Okay, we know that vector v can be written in the form of I, j, and k. Therefore, the vector v can be written as 2i plus 4j plus 3k. So this one is the vector v. So how to find the unit vector? The unit vector v is the vector v itself divided by its magnitude. So we need to find the magnitude of vector v, and the magnitude of vector v can be defined or can be found by using the formula x squared plus y squared plus z squared. So you can see here the x is 2, the y is 4, and the z is 3. Therefore, the magnitude of v will be square root of 2 square plus square root plus 4 square plus with 3 square. So 2 square will be 4 plus 16 plus 9. So you have square root of 29. So this one is the magnitude of v. Okay, so to find the unit vector, the vector itself, which is 2i plus 4j plus 3k, okay, you divide it by its magnitude, which is square root of 29. Therefore, what you will have here is 2 over square root 29i plus with 4 over square root 29j plus 3 over square root 29k. Okay, what is plus? Okay, it's either this one is, maybe this one is wrong. This one should be -3. I think this one should be -3 because the sign here is negative. Okay, the point is -3. So when the point is -3, therefore your sign will be negative here. We have negative sign here. Okay, so you have 4j minus 3k. So this one is the error. This one should be -3. Okay, so you have negative here. So you have negative here. Okay, this one is doesn't matter because -3 to the power of 2 is still 9. Okay, so you have square root of 29 as its magnitude. Okay, so this one is the unit vector for the vector in three-dimensional space. Okay, now we want to find what is the vector between 2 points. We need to find how to find the vector between 2 points. This is the similar one with the two-dimensional space before. Okay, it's just that we have additional point where it involve the axis z, so we will have the point z with its vector k. Okay, so let's say we have 2 points which is point A and point B. Okay, so we have, if you can see, we have 2 points here. You have point A, let's say point A is here and point B is here. So from origin to point A is the vector OA, position vector OA. From origin to point B is the position vector OB. Okay, so now we want to find the vector in between of this point, which is this vector. Okay, so if you see the direction here, you can actually find the vector OB by adding up the vector OA with this one because it will give the same direction. Okay, so OB is actually OA plus with AB. Okay, so if you want to find this vector AB, you just need to rearrange this one, bring this one to the left. So you will have the vector AB is actually the vector OB minus with the vector OA. Okay, so this one is how to find the vector in between of 2 points. Okay, you need to see the relationship between these 3 lines. Okay, because 2 point, okay, the vector 2 point, if you have 2 point here, you will have 2 vectors, which is you will have 2 position vectors. The first position vectors will be from origin to the first point. Let's say this one A, this one B. So this one is the position vector OA. Okay, and the second vector will be the position or the origin to the point B. So this one is the second position vector, which is OB. Okay, what you want to find is actually the vector in between of this point. Okay, and you know that you can find these 3 vector can be related to each other, where this vector is actually the sum of these 2 vector. We have learned before, it must be in the same direction and it must be meet at one point here. Okay, therefore you just need to rearrange to get what is the vector in between of these 2 points. Okay, so we will have the vector OA because A will be in the form of x1, y1, z1, and B will be in the form of x2, y2, z2. Okay, so the position vector OA will be x1i plus y1j plus z1k, while the position vector OB will be x2i plus y2j plus z2k. Therefore, if you want to subtract OB minus OA, just take this one. Okay, x2i plus y2j plus z2k minus with x1i, y1j plus z1k. Okay, so we have done before. x2 minus with x1, okay, for the vector I, y2 minus with y1 for the vector j, and z2 minus with z1 for the vector k. So we can find the vector in between of 2 points by using this formula. Okay. Okay. Therefore, if you want to find the magnitude of AB, Okay, it just need to be x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2 plus z2 minus z1 to the power of 2. This one is the same before, it just that it involves one more point here, which is z. Let's see example here. Okay, let A and B be the position vectors of the point 2, 4, negative 5 and 1, 2 and 3 respectively. Find the magnitude of AB and A plus B. Okay, you need to carefully read this example, this question. A and B is the position vector, means that we have from origin to A, the first one, and from origin to B, the second one. Okay, and the point A is 2, 4, negative 5. Therefore, the vector OA will be 2i plus 4j minus 5k. Okay, and the point B is 1, 2, and 3. Therefore, the position vector OB will be 1i, or you just need to put I, plus 2j plus 3k. Okay, this one is the position vector. Now, question asks you to find the magnitude of AB. Okay, and we know that if we have OA, we have OB. Okay, to find AB, the formula is OB minus OA. This one is the formula from this one, OB minus OA. Okay, so our OB is this one, I plus 2j plus 3k, minus with our OA is this one, 2i plus 4j minus 5k. Okay, therefore, to find what is AB, you just need to complete this one. So, I plus with I minus with I. So, I is 1 minus with 2 for the vector I. Then you have 2 minus with 4 for the vector j. And you have here 3 minus with negative 5. Okay, 3 minus with negative 5 for the vector k. Minus and minus will give you positive here. Therefore, 1 minus 2 is negative I. 2 minus 4 is negative 2j. 3 plus 5 is 8k. So, this one is your AB. Okay. Question asks you to find the magnitude. So, it's not done yet. You need to find the magnitude of AB. So, the formula to find the magnitude is the square root of x squared plus y squared plus z squared. So, what is your x? X is here negative 1. Y is here negative 2 and Z is 8. So negative 1 square will give you 1, negative 2 square will give you 4 and 8 square will give you 64. So total up is square root of 69. So this one is the magnitude of AB. Okay, so that one is the first one. Now, the next is, question asks you to find the magnitude of A plus B. Okay, the magnitude of A plus B. So we know that the vector A can be written as 2i plus 4j minus 5k, and the vector B can be written as I plus 2j plus 3k. Okay, so if you want to find what is A plus B first, therefore you need to add 2i plus 4j minus 5k, add with I plus 2j plus 3k. Okay, so what you need to do is 2 plus with 1 for I. So this one. Then you have 4 plus with 2 for j. And you have negative 5 plus with 3 for k. So now 2 plus 1 you have 3i, 4 plus 2 you have 6j, negative 5 plus 3 you have negative 2k. Okay, so this is the vector A plus B. So now what you need to find is the magnitude of this vector. So the magnitude is square root of x squared plus y squared plus z squared. So x is 3, y is 6 and z is negative 2. So 3 to the power of 2, 6 to the power of 2 plus with negative 2 to the power of 2. So 3 square is 9, 6 square is 36 and negative 2 square is 4. Therefore, you have the square root of 49 equal to 7 as a magnitude of A plus B. Okay. Sorry. So let's see next question, which is the question B. The question B asks you to find the magnitude of AB times with the vector B minus vector A. Okay. The magnitude of A plus B, you have find it here. This one is the magnitude of A plus B. We already have it equal to 7. So now you need to multiply 7 with the vector B minus A. So we need to find first what is B minus A. So this is our B. So B minus A will be I plus 2J plus 3K minus with 2I plus 4J minus 5K. Okay, so you have here 1 minus 2 for vector I, 2 minus 4 for vector J, and 3 minus negative 5 for vector K. Okay, therefore what you will have here is negative 1 minus 2 will be negative 1I, 2 minus 4 is negative 2J, and 3 plus 5 will be 8K. So this is B minus A. So question asks you to multiply 7 with B minus A because the magnitude of A plus B is 7. Just now we have already find it. Okay, so 7 multiply with this vector. What you need to do is just multiply them. Multiply this 7 to all of them. Okay, so 7 multiply with negative 1 will give you negative 7I. 7 multiply with negative 2 will give you negative 14J. 7 multiply with 8 will give you 56K. So this is the answer. Means this one is actually the scalar multiplication of the vector. Okay, and the scalar is 7, where the scalar here is the magnitude of A plus B that we have find just now. Okay, so this one is for question B. Next, for question C, the question asks you to find the unit vector parallel to A plus B. Okay, so unit vector for A plus B. So what you need to do is you need to find what is A plus B first. So just now you already find what is A plus B here. Okay, and you need to know that the unit vector is the vector itself divided by the magnitude. So you already have what is the vector of A plus B and what is the magnitude of A plus B. So you just use this one. So this is the vector 3I plus 6J minus 2K divide by its magnitude. So the magnitude is 7. Therefore, you will have 3 over 7I plus 6 over 7J minus 2 over 7K. Okay, so this one is the unit vector for A plus B. Okay, unit vector adalah vektor itu sendiri bahagi dengan dia punya magnitude. So dua-dua ni kita dah cari tadi. So kita just gunakan maklumat ni. Okay, so ini adalah untuk vektor yang melibatkan 3 dimensional, where 3 dimensional melibatkan point X, Y dan Z.